Hi guys, thanks a lot for listening to this tutorial video on linear regression. In today's video, we're going to show you how to run linear regression in SPSS. For this example, we'll take a database on the country macroeconomic indicator. We run multilinear regression in order to show you how you can use it in order to explain fluctuation of GDP, which stands for gross domestic product. GDP per capita of a country. Will show you how to explain GDP per capita of a country using other macroeconomic indicator like gross capital formation, which is investment, final consumption investment, final consumption, current account balance, population growth. We have also inflation and economic openness, which is a variable that measures the capacity of the country to perform according to its import and export. So to run a linear regression in SPSS, you just need to go in analyze and regression. When you are in regression, you go on linear, analyze, regression, linear, then click on linear. So you have this dialog box that gives you the opportunity to choose for a dependent and the independent variable. The dependent variable here is the variable that we are going to explain. The variable that we are going to explain here is a GDP per capita. So we use arrow to pull it into this dependent variable space. So to explain fluctuation of GDP per capita, we'll use a variable like gross capital formation. We'll select gross capital formation and put it in this. Another variable is final consumption, the current account balance, percentage of GDP. Population growth can also be used to explain GDP per capita. We also have inflation, which materialized by consumer price index. Select it and then use the arrow and put it in independent variable space. We have economic openness as a variable. We also have foreign direct investment, but we'll put foreign direct investment percentage of GDP. So while we have selected a dependent and independent variable, we should set some characteristic. Go on statistic, for example, those with option we need to have. By default, SPSS choose estimate of the regression and model fit. So we can also ask for confidence interval of our coefficient. We can also ask for covariance matrix, which is a matrix that will show us the correlation between different variables. So we can also on residual develop some statistic in order to analyze the residual. You can also choose R-square changes. You can also have descriptive statistic in our regression. Then you click on continuous. So we choose which thing we are going to plot. You can choose to have a standardized residual plot program and the normal probability plot, PP plot, which will help us decide whether or not our residual are normally distributed. Normal distribution is one of the hypotheses that is hidden behind linear regression. So in linear regression, residual should be normally distributed. So we can also plot the scatter of Z of residual. So we just select, you can select plot of the residual in X and Y axis. So we click on continue and we can also save on standardized predicted value, standardized predicted value. So we can also look at prediction interval of mean and individual or so on, or create coefficient statistics. So we will just let it at this for now. So we click on continue. Another option that you can choose is the entry probability and removal probability, which is 10%. So we will let default value as is set by SPSS, and then after all these parameters set, you just click on OK and the result will appear in the screen. So in the first table we have a descriptive statistic of GDP per capita. So we have a mean of GDP, standard deviation, number of observations in which mean has been computed. We have gross capital formation, mean and standard deviation. We have mean and standard deviation for all variables in our model and our linear model. So we also have correlation here, correlation between different variables. So we have Pearson correlation between our different variables. Pearson correlation between, for example, GDP per capita and gross capital formation is 0.049, meaning that correlation between variable and two variables just 4.9%. So the correlation is much higher between GDP growth and final consumption and expenditure, percentage of GDP, and the level of correlation is 47% correlation between GDP per capita and final consumption expenditure, which means that the sign of the correlation is positive, which means that when a GDP per capita increase, final consumption expenditure are the same. so increase in the same manner, and correlation contrary, GDP per capita is negatively correlated to population growth. Population growth can lead to a GDP per capita decrease. So that is just normal relationship. So we have also inflation, which is negatively correlated to GDP growth. So when there is more inflation in the economy, we can expect to have deterioration of living conditions materialized by a decrease of GDP per capita. So we can also make the same analysis among different variables. After correlation, we have variable enter and remove in the equation. All variables was enter in the equation, but not remove variable in our equation. So we have a summary of our model. We have our model which have a R of 66%, but the R square is just 43%, and the adjusted R square is set at 30%. So you can also have another result, regression and the residual. So we have for the regression 7 degree of freedom, mean square, and Fisher statistic, and significant in our model. So here's our coefficient table, which give in which size GDP per capita evolve when all explanatory variables are evolving. So we have constant which is significant here because p-value is less than 5% if we choose a 5% level of significance. So we also have growth capital formation, which have a coefficient which is not significant. The p-value is 36%, which is more higher to consider that gross capital formation significantly influence GDP per capita. So one of the variables that significantly influence GDP per capita is the final consumption expenditure in percentage of GDP. Significant is less than a threshold that, as I said, by 5%. The other coefficient is 69.26, which means that when final consumption expenditure percentage of GDP increase by 1 unit, so increase by 1%, GDP per capita increased by 69.26. GDP per capita was measured in dollar. Current account balance didn't statistically influence the variation of GDP per capita because p-value is higher than our threshold of 5%. If the threshold could have been even 10%, we could have not say that current account balance significantly influenced the variation of GDP per capita, which is our dependent variable. So another variable significant is the population growth. Population growth significantly influence variation of GDP per capita, and the influence, the coefficient is very high, which means that when population grow by 1%, GDP per capita also increase by 5,061 units. It can mean that there are more economic forces to produce in order to improve the living condition. You can also interpret all other coefficients using this statistical significance. But here is the confidence interval of our coefficient for variable significant like final consumption, investment. The level of variation of GDP per capita is 69, and the confidence interval at 95% is 33 to 106. So we can also have the same interpretation for any explanatory variable. We also have a predicted value. According to our model, we have the minimum, the maximum, the mean, the predicted mean, standard deviation, we have standard error predicted. For the graph, we have a histogram of the dependent variable, which is GDP growth, which is plotted here. So here we have a PP plot for the regression standardized residual. You see that our residual is most closer to this line, which means that we can assume that our residual according to the PP plot is normally distributed. So that is one of the hypotheses hidden behind linear regression. We also have a scatter plot of standardized residual and dependent variable as we have asked parameter. So that's it for this tutorial.